Hello, scholars. This is Mr. Lowe. I hope that all is well with you. Today, this video recording is going to cover section 2.2, which focuses on finding the slope of a line. Now, slope of a line is taught in Algebra 1. It's also taught in geometry, but it also shows up in Algebra 2 trig since we are working with linear functions. So just to give you a preview, there are several things that we're going to do today. We're going to go over the 4 types of slope, look at how to find the slope of a line given a graph, given 2 points, how to find the slope of a line that is parallel and perpendicular, how to find the missing coordinate given the slope and a point, and then finally calculating slope as a rate of change. So there are quite a few things that we're going to be going through today. Again, feel free to use this video to rewind, fast forward, to catch up on any content that you may miss along the way. All right, to begin, the slope of a line is also known as the rate of change. So when you see rate of change, you can automatically think of slope. So slope is simply how steep a line is. So if you've ever seen a handicap ramp, slope does come into play with regards to a handicap ramp. Now, there are 4 types of slope indicated in the graph in the graphs below. So a positive slope is a slope that rises from left to right. So the line should rise from left to right. Negative slope, the line will fall from left to right. So anytime you see a line falling from left to right, that's a negative slope. 0 slope means you have a horizontal line. So anytime you have a horizontal line, that means your slope is 0. And lastly, undefined slope is when you have a vertical line. So vertical lines all have undefined slopes. So those are your 4 types of slope. Positive, line is rising. Negative, the line is falling. 0, the line is horizontal. Undefined, the line is vertical. So keep those in mind as we go through our work today. So that takes care of definition of a slope. Let's go to finding the slope of a line given its graph. Finding the slope of a line given its graph. So if we have a graph, then to find the slope is very simple to conduct. First step, plot your points if they're not done for you already. So in the cases of examples 1, 2, and 3, the points are already plotted for you. But if they're not plotted for you, then you would plot the points and draw the line. Step 2, start at the lowest point on the line. So in the case of example 1, there's the lowest point on the line. Count the number of units that you would rise to get to the second point. So I'm rising 1, 2, 3, 4, 5, 6, 7 spaces to get to the other point. So count the number of spaces that you would rise, and then count the number of spaces that you would run. Running is either going to run to the right or run to the left. So if you run to the right, that means your final answer is going to be positive. If you run to the left, then your final answer is going to be negative. So in this case, 1, 2, 3. So my rise was 7. My run was 3. So if you remember from Algebra 1 and geometry, to find your slope, that is your rise divided by your run, which is 7 over 3. So a couple things to notice here. Slope is always represented by the letter M. Slope is always represented by the letter M. Your answer is always a fraction unless you were working with decimals to start the problem. If you were working with decimals to start the problem, then it would be okay to give your answer as a decimal. But your slope should always be a fraction, and it should always be reduced. So example 1's taken care of. Example 2. Now, notice with example 2, the line is falling from left to right. So that means if we go back to what we did originally, this should be a negative slope. So we should have a negative slope for example 2, just like we had a positive slope for example 1. So linking what we just did to what we're doing now. So example 2, same rules apply. Go to your lowest point and count your rise. So your rise in this case is 1, 2, 3, 4, 5, 6. Then count your run, which is 1, 2, 3, 4, 5, 6, 7, 8. So this time, since you ran to the left, that's negative. You ran to the left, so that's negative. So again, slope is rise over run. 6 over negative 8. That can be reduced to 3 over negative 4. So 3 over negative 4 is your slope. Finally, example 3. We're finding the slope of a line depicted by line C here. So the line is right there with your 2 points. So notice that this is a vertical line. So a vertical line corresponds to an undefined slope. So you're going to see why this is undefined. So again, we start at our lowest point, count the number that we would rise. So that's 1, 2, 3, 4, 5, 6, 7. So our rise was 7, but we don't have to run anywhere. We don't have to run left. We don't have to run right. So your run, in this case, is 0. So if we do our slope, rise over run, that's 7 over 0. You cannot divide by 0. You cannot divide by 0. So that means that's undefined. Your slope is undefined. So if your slope is undefined, do not put 0, because then you're saying that 7 divided by 0 is 0. That's not true. Also notice that the 0 is at the bottom of the fraction. The 0 is at the bottom of the fraction. So one key piece of business here, if you have any number divided by 0, that's going to equal undefined. That's going to give you an undefined answer. If you had 0 divided by any number at the bottom, that would be 0. So keep that in mind. 0 divided by a number gives you 0. A number at the top divided by 0 is undefined. So there is a difference between the two. So the main takeaway from part B is that the slope of a line, you're using rise over run. So that's rise over run. All right, so let's switch gears to finding the slope given 2 points. So if you're just given 2 points and you're not given a graph, now we use a formula to find the slope. So this formula, y2 minus y1 divided by x2 minus x1. Notice the setup of the formula. The y's are on top. The y's always go on top. The y's are on top. They always go on top. The x's are at the bottom. They always go on the bottom. So y2 minus y1 divided by x2 minus x1. Now, some teachers will teach it the other way around, y1 minus y2 over x1 minus x2. That's okay. Either way is okay. You just have to make sure you are consistent. Pick one format and stick with it. So, example 4. Example 4, the line passes through -2, 2 and 10, -7. So the first thing you should do is label your points. X1, Y1, X2, Y2. Label your points. Now, if you're real good at it, you may not need to label it, but I always strongly suggest you label. Now we go to our formula. So you have Y2, -7, minus Y1, 2. Y2 minus Y1 divided by 10 minus -2, X2 minus X1. First thing, of course, is the setup. Now we evaluate it. -7 minus 2 gives you -9. 10 minus -2 is 12. So you have -9 over 12. You have to reduce that. You can divide the top and the bottom by 3. So that gives you -3 over 4. And that is your final answer for the slope. -3 over 4, your final answer for the slope. So since this is a negative slope, that means if it was on a graph, your graph would be falling from left to right. So example 2, give myself a little bit more room here. Example 2, same rules apply. Label your points. Again, labeling may not be necessary depending on how strong you are with the concept. Same setup. Y2 minus Y1, so 2 minus -4, divided by X2 minus X1, 4 minus -5. So 2 minus -4 is 6. Remember, two negatives next to each other turns to a positive. That's why it's 6. 4 minus -5 is the same thing as 4 plus 5, which is 9. And 6 over 9 can be reduced. You can divide both of them by 3. So that's 2 over 3 as your slope. So we have a positive slope, which means this graph would have been rising from left to right. Would have been rising from left to right. So finally, example 6. Line F passing through -1, -3, and -5, -3. Once again, label your points. So your slope is, the y's go on top, so -3 minus -3, divided by -5 minus -1. The reason why we're working with a lot of the negative numbers is because that's where most people mess up the problem. That's where a lot of people mess up the problem. So notice how I am setting up the problem every time I'm plugging in a negative. If the first number was negative, then I didn't put it in parentheses. You can if you want to, but I didn't put it in parentheses. The second number, if it was negative, I put it in parentheses. That way you can see that two negatives are going to sit next to each other. So that's very important. So -3 minus -3, so that's the same thing as -3 plus 3, which is 0. -5 minus -1, that's the same thing as -5 plus 1, which is -4. So we have 0 divided by a number, which gives you 0. So this is an example of a graph that would be horizontal. This is an example of a graph that would be horizontal. So if you notice over the last 6 examples, we have done a situation of all 4 types of slope. Positive, negative, 0, and remember example 3 was undefined. So we've done a couple positives, a couple negatives, a 0, and an undefined. So you have now seen all four types of slope. All four types of slope. So again, use this to work backwards and forwards, check in with yourself, and as you're doing the homework, you can refer back to this video to see anything taught again. So part C. So part C, we now start applying the answer, applying slope. One of the applications of slope is dealing with parallel and perpendicular lines. Parallel and perpendicular lines. So if you remember from geometry, parallel lines do not intersect. Parallel lines do not intersect. So here's an example of parallel lines. Those lines will never intersect. So in order for those lines to never intersect, they have to have the same slope. They have to have the same slope. So both lines have to have the same slope. Perpendicular lines, if you remember from Algebra 1 and geometry, perpendicular lines are lines that intersect at a right angle. They intersect at a right angle. So notice in the diagram, line 1 and line 2, they intersect and make that right angle. They intersect and make the right angle. Algebraically, to make that happen, the lines have to be what's called opposite reciprocals. Opposite reciprocals. Your textbook calls it negative reciprocals. They're opposite reciprocals. So opposite reciprocals mean opposite. One has to be positive, one has to be negative. Reciprocals, one is the flipped over version of the other. So, for example, if line 1 has a slope of 2/3, so the slope of line 1 is 2/3, the slope perpendicular to that, the opposite of 2/3, the opposite of positive is negative, and if you flip 2/3 over, that's 3/2. So this would be the perpendicular slope. That would be the perpendicular slope. Easiest way to make sure you did it right, take your two slopes and multiply them together. If you get -1, then you did it correctly. If you get something else, you didn't do it correctly. Very easy way to point that out. So, for the example off to the side so that you can see how it works. The slope of a line is equal to -3/5. Find the slope of the line that would be parallel and perpendicular to this line. So, you just got to know the definition. So, a parallel slope, remember, parallel slope has to be the same. So, if you start with -3/5, you have to stay with -3/5. Perpendicular means opposite and reciprocal. That's where most people mess up this problem. They do one and not the other. Must do both. So opposite means either change from positive to negative or change from negative to positive. In this case, it was negative. We're making it positive. Reciprocal means flip it over. So instead of 3/5, you have 5/3. You have 5/3. So that's all parallel and perpendicular are. Once you know what to do, it's very easy to apply it. Once you know what to do, it's very easy to apply it. So let's see this in action with examples 1, 2, 3, and 4. So they are asking us to use our answers from parts A and B to make this happen. So example 1, find the slope of a line parallel to line A. So if we go back to line A, which was example 1, our slope was 7/3. So the slope of line A is equal to 7/3. So M means slope, A, we're referring to line A. We want a parallel slope. So your slope parallel, remember, so parallel means the slope has to be the same. So that's also 7/3. So that's it. That's all it was asking you to do. Make a parallel slope to that. Example 2, find the slope of a line perpendicular to line B. So line B, which was example number 2, was 3/-4. So the slope of line B was 3/-4. So now we're doing perpendicular slope. So perpendicular is opposite. So instead of negative, it turns positive. And then we flip over the fraction. So that's 4/3. So a couple things to note. Number 1, you do not have to put the plus sign. Number 2, if one part of the fraction is negative, it's all negative. So changing from negative to positive, you don't have to change both numbers. If one part of the fraction is negative, it's all negative. All right, example C. Are lines C and D parallel, perpendicular, neither? So now we're making a value judgment. So let's look at the two answers. Line C was undefined. Line D was -3/4. So the slope of C was undefined. The slope of line D was 3/4. Let's make sure I got that right. Yes, -3/4. So parallel, they're not parallel because they're not the same. So that's out. Perpendicular means one has to be the flipped over version of the other, and it has to be the opposite. So to get undefined, for example 3, that was 7/0. So the answer that we got for C was 7/0. If I flip 7/0 over, I'm not going to get 3/4. So it's not perpendicular. So your answer is neither. It is perfectly okay to get neither. It is perfectly okay to get neither. It will happen. So we do the same thing with E and F. So that's 2/3 and 0. So the slope of line E was 2/3. The slope of line F was 0. So I made 0 a fraction so that it could match up as a fraction with line E. They're not the same, so they're not parallel. If I take 2/3 and flip it over, that's 3/2. That doesn't match up with 0, so it's not perpendicular. So again, your answer is neither. Again, it is perfectly fine to get an answer of neither. It is perfectly fine to get an answer of neither. That doesn't mean you did anything wrong. It is what it was. So remember, parallel, same slope, perpendicular, opposite reciprocal slope. All right, so second application of slope is when you are finding missing coordinates given the slope and a point. So this time, what's going to happen is the following. You're going to be told that the slope is equal to something. You're going to be given the slope. You're also going to be given 2 points. One of the points is going to be completely filled in. The other point is going to have one number given and one number missing. One of the numbers will be given, one of the numbers will be missing. So now we have to solve for that number. To do this, we're going to be using equations and proportions similar to what we did in unit number 1. So now we're applying something we learned in unit number 1. So first example is given to you. So I'm going to explain this first example out. So the example that's done for you. Find k such that a line passing through 4, 5 and 7, k has a slope of 1/2. So first step is label your points, label everything that was given to you, and plug it into the slope formula. Label everything that was given to you and plug it into the slope formula. So y2 minus y1 would be k minus 5. x2 minus x1 would be 7 minus 4. And then your slope is 1/2. So plug in everything that's given to you first. Second step, simplify the expression. So you can simplify 7 minus 4. That gets you 3. Make the problem a little bit easier for you to solve. So now you have a fraction equal to a fraction. That's a proportion. That's a proportion. So remember, with a proportion, you can cross multiply. So now we're going to go ahead and we're going to cross multiply. So that means we're going to take 1 times 3, and we're going to take 2 times k minus 5. So again, you have 1 times 3, which would give you 3, and 2 times k minus 5, which, see, I made a mistake here, so we'll fix that right now. 2 times k is 2k, and 2 times 5 gives you 10. 2 times 5 gives you 10. So to finish off solving the problem, so since I made the mistake, we'll go ahead and fix it. Like I said, it is very much okay for you to make a mistake. Let's go ahead and get it right. So add 10 to both sides. You get 13 equals 2k. Divide both sides by 2. So you have k equal to 13 over 2, or 6.5 if you have the decimal. So yes, fraction answers can happen. Decimal answers can happen. That is what it is. That is what it is. That, and hopefully you saw I made a mistake, so that means it should be okay for you to make a mistake. Nobody's perfect. So now let's look at example number 1. So example 1, find k such that a line passing through 5, 2 and k, 12 has a slope of -5. So first step, label everything that was given to us. Label everything that was given to us, and then plug it into the slope formula. Again, if you don't need to label it, that's fine, but make absolutely certain you put everything in the right place. So m is the slope, that's -5. We're going to make it a fraction so that, because everything else is a fraction. y2 minus y1, 12 minus 2, x2 minus x1, k minus 5. So that's your first step. Get everything plugged in. So next step, let's make this a little easier on ourselves. 12 minus 2 is 10. So -5 over 1 equals 10 divided by k minus 5. There's our second step. Now we cross multiply. So cross multiply means -5 is going to multiply times k minus 5, and 1 is going to multiply times 10. So we take care of our cross multiplying. -5 times k minus 5 equals 1 times 10. So now we're just solving an equation. -5 times k is -5k. -5 times -5 is +25. 1 times 10 is 10. Then we finish solving out. Subtract 25 on both sides. That gives you -5k equals -15. Divide both sides by -5. K equals +3. So k is equal to +3. And that's it. Problem's over. That's that. Problem's over. So again, it's not a hard problem. It's just one that has multiple parts, so you have to pay attention to the multiple parts. So one more example of a problem of this type. Find k such that a line passing through -3 comma k, so there's my x1 and y1, and 3, -5, x2, y2, has a slope of 3/2. There's my slope. So notice that I read through it and labeled it all at once. So we're now ready to plug in y2 minus y1 over x2 minus x1. The slope is 3/2. y2 minus y1 is -5 minus k. x2 minus x1 is 3 minus -3. So everything is set up and ready to go. All right, so since everything is set up, we've got 3 minus -3 that we can simplify. So we're going to simplify that out to be 3/2 equals -5 minus k over 6. So we're set up and ready to go. 3 gets multiplied times 6. When we cross multiply, 2 gets multiplied times -5 minus k. So we took care of the cross multiplying. Now this is just an algebra problem. 3 times 6, 18. 2 times -5, -10. 2 times -k, -2k. To solve the equation, add 10 to both sides. So 28 equals -2k. And then divide both sides by -2. So you've got -14 equal to k. -14 equals 2k. So of course, if you ask yourself, well, how do I know I did it correctly? Very simple. Take k, plug it into the point, and then go find the slope. As long as the slope is 3/2, then you did the problem correctly. If it's anything else, then you may have done something wrong. It could be a computational error, or it could be an error when you solved it. So just be careful as you're working the problem out. All right. So we're just about finished with slope and rate of change. So now we're going to actually work with it as a rate of change. We're going to work with it as a rate of change. So in real world terms, the slope of a line is rate of change. So we are still working with the slope formula, y2 minus y1 over x2 minus x1. So now you're looking at the change of things, how things change. So when you're deciding what to set up, Whatever you can, the change in what you can control goes on top. What you can actually what you cannot control goes on top. The change in what you can't control. Now, in science, that's known as the dependent variable. That's the dependent variable over the change in what you can control. That would be your independent variable. What you can control versus what you can't control. Now, most of the time when you have rate of change, it's given in the problem how it should be set up. But if it's not, you have to think to yourself, what can you control and what can't you control? Whatever you can't control goes on top. Whatever you can control goes on the bottom. But know that most of the time, if you read the problem carefully enough, it's going to tell you how to set it up. Case in point, example 1. In 1.5 hours, you drove 180 miles on your way to a college visit. So, key information, in 1.5 hours, you drove 180 miles. After 4 hours, you've gone 570 miles. Find the average rate of change in your speed in miles per hour. So, since they're telling you miles per hour, then your rate of change is going to have miles on top over hours on the bottom. So they're telling you how to set it up. They're telling you how to set it up. So let's work this problem out. 1.5 hours, you drove 180 miles. So that's 1.5, comma, 180. You drove 1.5 hours. You went 180 miles. You can control how long you drive. You can't control how many miles you go. And 4, comma, 570. So hours, miles. So to solve it, all you're doing is finding the slope. To solve it, all you're doing is finding the slope. So it's the same y2 minus y1, x2 minus x1 formula. So x1, y1, x2, y2, 570 minus 180 divided by 4 minus 1.5. So 390 divided by 2.5. So now it comes a point in time in today's festivities in which you let the calculator do a little bit of work. So that's 156 miles per hour. So you're covering 156 miles an hour. So again, a rate of change is not difficult. You just have to do a little bit of reading to figure out what's going to go where. You have to read a little bit to figure out what's going to go where. All right, now example 2 is a little different because it's going to ask you for 2 different things. You are typing a paper at 5:15. You have typed 275 words. By 5:27, you have typed 660 words. Find the average rate of change in words per minute. Then use your rate of change to predict how many words you would have typed by 6 p.m. So this is a 2-part problem. It's a 2-part problem. So you need to find the rate of change. So ROC, rate of change. And you need to figure out how many words by 6 p.m. So let's go ahead and solve out. So 5:15, you've done 275 words. 5:27, you've done 660 words. So you're trying to figure out what is your rate of change in words per minute. So rate of change would equal to the difference in your words, divided by the difference in time. So the time aspect is easy to figure out. To go from 5:15 to 5:27, that's 12 minutes. $275 to 660, you're subtracting the two numbers. So it's just like finding the slope. 660 minus 275 is 385. 385 words. So if we divide the two out, you get 32.08333, so about 32 words per minute. 32.1 words per minute to be exact. All right, so there's our rate of change. Now we need to figure out how many words will we have typed by 6 o'clock. So think about where you stopped. 5:27, you had 660 words. So that's the last piece of information they gave you. So you're trying to go from 5:27 to 6 o'clock. 5:27 to 6 o'clock, that's 33 minutes. So you're going to type for 33 more minutes. You're going to type for 33 more minutes. So that means take where you stopped, so that's 660, plus 32, we'll say 32, times 33 more minutes. So let's think about where everything came from. So 660 is the last piece of information they gave us. 32 was your rate of change. 33 was how much time would pass from 5:27 to 6 o'clock. So that's where all the numbers came from. Color coded for you to see it. So now we just do the computation. 660 plus 32 times 33. 32 times 33 is 1,056. Add the 660 that you already used. That's 1,716 words. 1,716 words. So this is a multi-step reading comprehension combined with math type problem. Yes, you're going to have problems that are like that. It is what it is. It is what it is. So let's do one more example together before we close up shop on this lesson. In 1900, the average cost of a movie ticket was $4.25. In 2015, that average cost was $8.45. Find the average rate of change in price per year. Then use your rate of change to predict the estimated cost of a movie ticket in 2024. So let's think about what they gave us. In the year 1900, the cost of a movie ticket was $4.25. In 2015, that average cost is $8.45. Find the rate of change in price per year. So rate of change, they said price per year. So it means the price goes on top, the years go on the bottom. So price goes on top, years go on the bottom. So x1, y1, x2, y2. Use your slope formula. Remember, slope is also rate of change. So 845 minus 425 divided by 2015 minus 1900. 2015 minus 1900. So 845 minus 425 is $4.20. 2015 minus 1900, 115 years. 115 years. So if we divide this out, that's roughly about 4 cents. So you got 0.036. So that's 4 cents a year. 4 cents a year. That is your rate of change. So rate of change, again, is just finding the slope. Now we use this to predict the cost of a movie ticket in 2024. So we're trying to find what is the 2024 cost. So if you're going from 2015 to 2024, that's 9 years. That's 9 years. So example 3 is very similar to example number 2. Take the last data point that was given to you. So the last data point that was given to you was $8.45. The rate of change, 4 cents a year. And how many more years you need to tack onto this? 9 years. So that's $8.45 plus 0.04 times 9 years. And then all that's left is to do the computation. 845 plus 0.04 times 9 is 0.36. And if you add those together, you get $8.81 in 2024. Now, is that what it probably is going to be? Probably not. Most of us who have been to a movie theater know that movie tickets are definitely not $8.81. But based off of the information that we were given, that's what we have to work with. That's what we have to work with. And the main thing is for you to see how to use the slope to calculate a rate of change, and then how to use your answer for the slope to predict something else. How to use it to predict something else. In most stages in your life, you're going to be using what you've already done to predict what you will do in the future. That's how they calculate insurance for you. That's how they calculate salaries over time for you. So a lot of things that you will encounter in life uses a rate of change and uses prediction to figure out where you're going to be. With that being said, this completes the lesson for all of section 2.2, which is calculating the slope. As you can see, this is roughly about a 50-minute lesson. So when I upload this to YouTube and Google Classroom, I will put time markers to tell you at what time are we doing rate of change, what time are we doing slope using a graph, what time are we doing parallel and perpendicular lines. That way you can skip to what you need the most help with. But definitely watch the video, pay attention to the instruction, and ask questions as you have them. With that being said, I hope you have a great rest of your day, and I will talk to you soon.